So, so we started answering these questions, but we didn't get to finish them. We got to we found the mean, we found the standard deviation. Okay, so we use the calculator on tests and quizzes. I'm not going to ask you to do it by hand. I'm not going to ask you to find the mean by hand. I'm not going to ask you to find the standard deviation by hand. You can use the calculator. That's what it's there for. It helps us go faster. But help me. How do I get to the mean and standard deviation? What are the calculator actions, buttons that I push? Yeah, Danya? There you go. So you need to have the numbers in one of the lists, L1, L2, L3, whatever list, right? And then you go to stat, and then you go to calc. Let me pull up my calculator here. All right, let's see. So you guys know how to put numbers in, put lists in there, right? We've talked about that. So you the list has to be the list you're trying to find the mean and standard deviation. They have to be there. Okay. So if they're not there, then it won't be able to find the mean or the standard deviation. Okay. So once you have that done, now we need to find these numbers here. These numbers are X bar is the mean. This circle with the tail on it, that's the standard deviation we're going to use. Okay, so how to get there? We did that last time, but just a reminder. So we go to stat, we go to calculate, and then you hit number one var stats, one variable statistics. You tell them where the list is. Where is my list? Frequency, we don't touch. Frequency list, we don't touch. And then we hit calculate, and there are the numbers. X bar, remember the symbols. X bar is the average, the mean. We don't use S of X. We'll use that later in the year, but not right now. We use the circle with the X, the circle with the tail and the X, sigma of X, okay? When you're rounding a number, go 3 places. Always go 3 places past the decimal. So for the standard deviation, I would go 8.484 because the 6 behind it says go up. For the mean here, I would say 24.833 and stop there. Okay. Okay, so that's where we finished. Now, so let's go back to here. Got a couple things. Since we have the standard deviation, 8.484, how do I put that into context? Context is key here, always context. Context means put it in a sentence that would make sense for this problem, right? So you can use a sentence frame. You can use a sentence frame. The sentence frame says, on average, each value in the data set is, that's where you put the standard deviation. So the standard deviation goes here. So 8.484 units. Which unit goes with 8.484? Grams, yeah, because it says at the top, in grams. Grams away from the mean just 24 grams. So what this says is each of those numbers is on average about 8.5 grams away from the mean. Now, are they all 8.5 grams away from the mean? No. I don't think any of them are 8.5 grams away from the mean. But on average, they are. That's the spread. Remember, it's the spread. So you see the 9 hamburger, the one with the least amount of fat in it, the hamburger? What if I change that number? So what if I change the number? So no more 9. Or just take it away. Just take it away. Let's just say I took it away, just like that. Would my standard deviation go up Would this number go up? Would it go down? Or would it stay the same? Why would it go up? Yeah, that's the average, but I'm talking about, you're right about the average. You're right about this number, right? This number would go up. The average would. But what about this number here? This number here, would that go up or down? Ikwan? Yeah, 9 is an extreme number, right? It's an extreme number because it's on the low side, right? 9 is 13 away from the mean, right? So if I took that away, there's not as much spread. The spread goes down. So this number would go down. Okay? Yeah, good. So, just like this, watch. It's easy to do on the calculator when you have the calculator. Just watch mine. You don't have to do this on your own, just watch mine. Let me go to my list. Here's my list here. Now, what I'm going to do with 9 is I'm going to take it away. I'm going to delete it. No more 9. Now let me go. Now it's 7.325. That's smaller, right? It went down because 9 was one of the extreme numbers. Okay? Let me put 9 back in. Let's take out another number. Yes. If 9 wasn't an extreme number, would it go down or will it stay the same? That's what we're going to talk about right now. We're going to talk about that. Let me add 9 back in so before I forget. Let's take away one of the other numbers. Let's take away one of the other numbers. Let's take away a number in the middle. Let's take away the number that's closest to the mean, 24. 24. What would happen if I took away 24? Would the standard deviation go up, go down, stay the same? Why up?
Because when you're finding standard deviation, you have to divide, there would be less lower number there.
Yes. So 24 is exactly pretty much on top of the mean, right? They're pretty much on top of each other. There's no spread. So if I took that away, that's increasing the spread because now I don't have that included. So watch, divide. There we go. It went up a little bit, 8.857. It went up a little bit, not too much, but it did go up a little bit. Okay. That's what happens when you do that. Sometimes they'll ask you a question like that. They'll ask you, what happens if I took this number away? What happens if I added this number? What happens if I took this number away? What happens to the standard deviation? Okay. All right. So let's go back. Let's finish this. So the properties. These are multiple choice questions waiting to happen right here. Multiple choice questions waiting to happen about this. A lot of the multiple choice questions won't be things you need to add or subtract or use the calculator. It'll just be things that you either know or you don't know. Okay? These are the types of stuff. On the group test, yes. On the individual test, no. Okay? So standard deviation, what about it? Measures spread about the mean and should only be used when the mean is chosen. So that's what when we're talking about symmetric data, okay? Equals 0 only when there is no spread or variability. What does that mean? How do I get no spread? All numbers are exactly the same. Yep, if all numbers are exactly the same, standard deviation is going to be 0 because there's no spread. Another word they use a lot instead of spread is variability. Variability is the same thing as spread. They mean the same thing. No difference. Okay? Like the mean, it is not resistant to outliers. So if I was to include an outlier, it would do things to it, right? If I was to add a big number, let's say there was a super Mondo burger that they just came out with and it weighed 200 grams. Thing was just monster. That would make the mean go up and standard deviation go up. Okay, it might be an outlier. We'd have to check that, but it might be an outlier. Probably would be an outlier. We could check that on the calculator, right? And this is the guy you're looking for. This is the guy you're looking for on the calculator. That's the guy you're looking for, not S of X. We'll use that, but later in this year. We're not there yet. We're using that guy right there. That's the guy we use for standard deviation. Okay. All right. Okay, so last thing you're going to do on the notes is this question here. Okay. Use the calculator, answer the questions, and we'll go over it in a few minutes. And then I have some practice questions I want to ask you, let you guys think about. So just work on this right now, and then we'll go over the last part. Okay, so I have the mean up here and the standard deviation. Those are the numbers from the calculator. In plain English, so now we're talking about minutes studying. So the average time studied for these students, there's 9 students, is 35.556 minutes. I should label that minutes, right? That's how, on average, that's how much time they spend studying. That number varies. On average, each value in the list will vary by about 26 minutes, 26, 27 minutes. Okay. So that's to explain the number, explain the meaning. If you're not sure, just use the sentence frame. That's what the sentence frame is there for. Okay. Once you're more comfortable with it, then you can start putting in your own words. But for right now, just use my words. Okay. Yeah. John?
I double checked mine. I don't think I put any wrong. I think you might have made a mistake with putting those in. 0, 25.
0, 25, 30, 60, 90, 45, 45, 15, 10.
No, I definitely did something wrong. Calculate list stats. Calculate.
Make sure it's list 1 or wherever you have your list. I'll help you in a second. Yeah, we're almost done. I'll help you in a second. Okay. Let's see what else. What if I were to do this? What if I doubled every number there? Doubled every number in my list. Doubled all of these guys. Doubled it. Not 0 anymore. Or still 0 because it doubles 0, 0. Not 50 anymore. Or not 25. Now it's 50. 60, 120, 180, 90, 90, 30, 20. What would happen to the mean? Would the mean go down, go up, stay the same? I've literally heard all 3. So this is what I want you to do. Gather your thoughts, talk about it with the person who's closest to you. Whoever's closest to you, talk about it with them, come up with an idea, and then we'll talk about it. Okay? Okay, so here we go. Raise your hand if you say the mean's going to stay the same. Mean will stay the same, exactly the same, no difference. Oh, really? Okay. Go down. The mean's going to go down. Mean's going to go up. Makes sense that the mean goes up, right? All of the numbers are going up. If all of the numbers are going up, the mean's going to go up too. How about this one? Double each of them. Again, so 0, 50, 60, 120, 180, 90, 90, 30, 20. What's going to happen to the standard deviation? No calculators. What's going to happen to the standard deviation? No calculators. Not allowed to touch your calculator for this one. What's going to happen? Why would it go up? So the standard deviation measures the spread, right? So if I doubled each of them, what's happening to the spread? Are they still the same spread apart? You still have 0, but what's happening to the biggest number? Yeah. So there's more spread. So it's going to go up. Okay. It's going to go up as well. Okay. All right. So let me give you some, before you start your practice test, let me give you some other practice stuff that I had on here that I'll show you. Here we go. Try this one. one second. Okay, so what I want you to do is think about it for 30 seconds, talk about it for 30 seconds. We'll talk about it together. Okay, so think about it for 30 seconds. Don't say anything, just read it, see what you could think of, and then you'll talk about it for 30 seconds. Gather your thoughts first. So which of the following must be true? Okay, so 1, data set A contains more data than B. What does that mean, more data? More numbers, longer list, right? Can we tell that from box plots? No, we can't tell. We cannot tell that from box plots. Okay, so number 1 can't be true. We can't tell. It could be, it could not be. We don't know. We don't have enough information. So that one we cross out. Number 2, the box of set A contains more data than the box of set B. Well, if number 1 was false because we couldn't tell, how is number 2 going to be correct? Can't be, right? Number 2 can't, because it says the same thing. Oh, so it talks about the box. Talks about the box here. The box contains more data. We don't know that. We don't know that, right? 3, the data in set A have a larger range than the data in set B. So what is range again? Biggest to smallest, maximum versus minimum. Yep, this one I agree. A has a bigger range. A's range goes from like 12 to 46 or something like that. B's range goes from about 15 to 44-ish. So yeah, I would agree. Letter B. Letter B. Good job. Okay. So let's try another one. I have a couple more in here. Here we go. This one's a little tougher. Think about it. Standard deviation talks about how far each value is from the mean. So the one with the biggest standard deviation has more values that are further away from the mean, right? That makes it go up. Okay, so let's look at that. That's what we're looking at. So the first thing we got to find is kind of the mean. Where is the mean, right? A is skew right. So the median is going to be so on A, which one's going to be bigger, the mean or the median? The mean. The mean's going to be bigger on A because the mean wants to go out to these extremes, right? The opposite's true on B. Okay. So the mean would be somewhere like right around here. The median would be a little bit less. Okay. Same thing over here. The mean would be somewhere around here. The median would be a little bit more here. C, where is the mean and the median for C? Right on top of each other, right in the middle, right? Symmetric, right in the middle. How about for D? Where's the mean and the median for D? The right smack dab in the middle because it's symmetrical. Same thing with E, right? So now that we know that, which one has the most stacked bars further away from the mean? The most stacked bars further away. Let's see. So B, we said the mean was right about here. Yeah, we have some stacked bars that are further away, but these over here are really low. Same thing over here. We have some stacked bars that are further away, but not on the other side. On one side, yes, but not on the other side. Here, everything going away from the mean is getting smaller. So that one's not going to be it. What's true about D? As I go farther away from the mean, the bars get bigger and bigger. Either all the same. So I would say D is the best answer. D is the best answer. Okay, it's the best answer. That's the thing in a lot of multiple choice questions. You're looking for the best answer, not necessarily the correct answer, because sometimes there'll be more than one like reasonable answer. You're looking for the one that's the most correct, the best answer. Okay? So D, yeah, everything's running away from D. The mean's in the middle, that's the smallest. Everything's running away from D. Okay? Which one has the smallest standard deviation? Which one has the smallest standard deviation? C. C has the smallest. Right here. Everything running away is small. So right here in the middle is the tall ones. On the edges, the furthest away are always the smallest ones. So C would have the smallest standard deviation. Okay. All right, one more. One more, and then I'll let you guys work on your practice test. Okay, so this is what I want you to do. This is not a multiple choice question. It's a talk about it question. Okay. So I want you to compare the distributions. These are two separate classes from biology classes. Two separate classes. I don't know how many students are in each. They didn't give us the numbers. They just gave us the data, the box plots. So I want you to tell me, compare the two of them. Compare means what do they have similar? What do they have not similar? What are the four things that we need to talk about when we're discussing comparing or describing distributions? Shape is one of them. We want to talk about shape, definitely. What's another one? Outliers. Are there any outliers? Does one have an outlier? Does the other have an outlier? Do they not have outliers? Do they both have outliers? What's the other one? Center. Where's their centers? Either mean or median, whichever one you know. And what's the last one? Spread. Range, IQR, standard deviation, whichever one we know. Okay? So what I want you to do right now is talk about it. You don't have to write it down since you don't have these on your paper, but talk about it. How would you answer? That's what I want to know. Okay? So I'll give you about a minute or so. Talk about how you would answer. Talk it out instead of writing it out. Okay? All right, so shapes. Are shapes actually not. Let's not start with shape. Let's start with outliers. Are there any outliers? No. How do we know there are no outliers? No stars, no dots. That's the best we can do. We don't have the data, so we look for that. Centers. Centers. Who has the higher center? Who has the lower center? Data set 2 has the higher center with 45. Is that the mean? So the median, right? We want to say the median for data set 2, while the median for data set 1 is about 35. Okay. Spread. Spread. What's that? Okay. So we would say IQR of data set 1 is roughly 15. Yeah, or 15. The IQR of data set 2 is 15. So they're the same, but they're not exactly the same. What's the differences in their IQR? Where the box is, yeah, where the placement of the box is, right? The box is a little bit higher for data set 2 than data set 1, right? They're exactly the same distance apart, but one is a little bit higher. That's important. If you were in biology class, which class would you want to be in? 2, because the students look like they tend to, most of this, the middle 50% looks like they tend to do better. All right, that's the one I want to be in. So that's important. Okay. Shape. All right, so go back to shape. This one's a little tough. How would we tell shape? Not the median. It won't. Yeah.
compared to where the median is to the rest of the data.
If we could compare the mean and the median, yes. If we could compare the mean and the median, do we know the mean for each of them? For either of them? No, we don't. We don't. So we could compare the mean and the median. Absolutely. So we're out of luck there. Well, so you have three options, right? Symmetric, skew right, skew left. This is what I do. This is kind of like what I do. I kind of picture this in my head, or I draw a picture. So I'm going to do data set 1 here. Data set 1, data set 2. So this is 1, this is 2. Why is data set 1? So data set 1, look at the distances. Look at the distances between. So distances, I mean this distance here, this distance here, this distance here, and this distance here. What do short distances mean? Like this one right here is a lot shorter than this guy here, or this guy here, or especially this guy here. Yeah, there's 25% in here, right? So that means, how does that correspond to a histogram? Taller bars. That's where the taller bars are going to be. So the taller bars are going to be around 30, 35. Okay, so the taller bars are going to be around, let's see, I don't know how they did this, but let's say 20, 25, no, let's do 30s, 30, 40, 50, 60. So right here, the tallest bars are going to be. What do longer distances mean? Shorter bars. So this guy, data set 1, is going to have short bars from 45 to 60 because that's the longest one, right? So from 45 to 60, it's going to have shorter bars. I don't know how tall, but they're shorter. How about the first 25%? That's not the shortest. This is the shortest right here. That's the shortest, right? Aren't these two about the same? The distances here? No, yes, maybe so. So distances, watch my cursor. Watch my cursor when I say distance. Distance from the edge to here, that's a distance. From here to here, that's a distance. Here to here, that's a distance. And then here to here, that's the distance, right? Okay. So we already said which one's the shortest, this guy here. We already said which one's the longest, this guy here. Tell me about the other two. Okay, they're the same. Are they the biggest? Are they the smallest? Are they somewhere in the middle? Tell me about them. Okay, are they the biggest? Are they the smallest? Or are they somewhere in the middle? They're somewhere in the middle, right? They're somewhere in the middle. So bars somewhere in the middle. What does that look like? Skewed right. It looks like skewed right to me. Skewed right. Okay. Let's do it for data set 2. Where's the high points for data set 2? Where's the high points for data set 2? $45 to $50. Okay, so 45 to 50 are going to be the high bars. 45 to 50. Okay, where are the low bars? 20 to 35 are low because there's a lot of spread there, right? So 20 to 35 are a lot of spread there. Okay, what about 35 to 45 and 50 to 60? Low, high, medium. Medium. What does that look like? Skew left. Skew left. I'll give you another example. I'll give you another example right here. Look at number 1. Tell me about number 1. Well, okay, so what do you mean by symmetrical? Because we have 3 different types of symmetrical, right? So where are the high bars? Where are the low bars? Where are the medium bars? Where are the, where are all those? Sketch a picture like this. Sketch a picture like this, because I'm going to show you some other pictures and I want you to match it. So sketch a picture in your head or on paper, because I'm going to give you some matching that go with it. Let's do 1 and 2. So let's do 1 and 2. Those are pretty extreme. 1 and 2 are pretty extreme cases. So give me a sketch for number 1, box plot number 1, box plot number 2. Where is the high points going to be? Where are the high boxes going to be? Where are the low boxes going to be? Where are the medium boxes going to be? Okay. Give you a few minutes to do that. And then I'm going to show you some ones and you're going to pick out the winner. Oops. Give me 1 second to get it back. One and two. Just 1 and 2. Where are the high bars going to be? Where are the low bars going to be? Where are the medium bars going to be? Uniform. Okay. About another minute, and then I'm going to give you some choices. I'm going to give you 6, 7, 8 choices, and you got to pick which one best matches it. So where, for blocks plot 1, just for number 1, where are the high bars going to be located? Where are the high bars going to be located? Yep, 45 to 55 about. 45 to 55, I would expect to see something very, very high. Higher than the others, right? What about box plot 2? Where am I going to see the high bars at? From 0 to 10, I would expect to see some high bars. And from 90 to 100, I would expect to see some high bars, right? That's what I'm looking for. So now let's look at the ones that match with it. See if I can, I'm trying to make them as big as I can. So let's go 2 at a time. Let's go 2 at a time so it's big enough, because right now it's small. Or let's go 4 at a time. I can fit 4 in here. So do any of these match 1 or 2? Mm-hmm. Would B match 2? What are we looking for with 2 again? We said high at the beginning and high at the end, right? That shows that. B fits. Okay. C, would C fit box plot 1? Okay. Let me show you. That's not all of them. There might be better. So let me show you the last 4. Do these fit better than the others? Well, where were the high bars at? Where were the high bars at? You got to look at specifically where. For number 2, where were the highest bars at? For number 2, 0 to 10, right? So does this guy have the high bars at 0 to 10? No, that's pretty low at 0 to 10. Here, 0 to 10 is the highest, right? So I think B would fit it better. B would fit it better. And then, yes, C goes with a 1 too. C goes with 1. Okay? Those are the types of questions, multiple choice questions you're going to have. Because did we need to do any math in terms of adding, subtracting, multiplying, dividing? No, you just had to use your knowledge. You had to use your brain to kind of think it through, and you know what a histogram does. You know what box plots do, all of that good stuff. Okay? Okay, so practice sheets. Just keep it with you. Don't bring it back tomorrow. You don't have to do it. We'll do it in class tomorrow. Okay? So just keep it somewhere safe so you bring it tomorrow. We didn't get a chance to start it all day tomorrow. All we're going to do is work on that practice. Okay?